time we'll move on to Chapter 10. Please remember that I did put the homework assignments on Springboard. If you go to Quizzes and then to down there's a Chapter 8 and a Chapter 9. You like how I picture everything in my mind? You can like see me working through the Springboard. And so Chapter 8 and Chapter 9, and there's like 16 questions in one and 20 questions on the other. So if you missed any of the assignments or anything like that, now would be a good time for you to make those up and get lots of good homework points. So today we're going to be finishing up Chapter 9, and it's not an insanely long one, but it does have some good videos that go with it. And so we're going to be talking a little bit about monogamy versus polygamy. And so you may have heard of those terms before, but usually not in relation to science. Usually you hear about it in relation to relationships, like monogamous relationships, or polygamous relationships are like where they have like one husband and then sister wives. That would be polygamy. And so here we're going to be talking about it in terms of mating patterns across human and animal cultures. So one of the ones we're going to be focusing on today is the elephant seal. And this is an example of two very large males, and they are fighting over a group of females. So these large males can be 13 feet long. They can weigh 2 tons, so more than your car. And in one study with 115 males, the 5 highest ranking males fathered 85% of the offspring. So imagine that. Only 5 males are the ones that get to have almost all of their genes passed along to their offspring. And so in looking in the difference between mating systems, we have polygamy, which is where some of the individuals attract multiple mates. So I don't know why sister wives always comes to my mind. Or other individuals attract none. And then monogamy is where individuals, male and a female, mate and then remain with just one other individual for their entire mating amount of time. And so then we can subdivide polygamy into polygyny, which is individual males mate with multiple females, and polyandry, which is where individual females mate with multiple males. So monogamy is 2 individuals, polygamy is 1 with multiple, and so if it's polygyny, it's males with multiple females, and if it's polyandry, it's females with multiple males. So some of the advantages of this. If we have our elephant seals, which are these guys up here, notice that the one dominant male elephant seal, the biggest and the baddest and the strongest of them, we've got one guy here, and he's going to father almost all of the offspring. And then we have low-ranking male elephant seals, so it makes you feel kind of sad for those elephant seals. This one guy is getting all the action, and these guys are getting none, except for one maybe manages to sneak in there while that guy's asleep and get one of the females. And so almost all of his genetic information is going to be passed along to almost all of the offspring. And this pack of blue guys here are going to get to have very few, if ever, have one at all. And so in an extremely polygynous mating system, such as elephant seals, the vast majority of males have no reproductive success at all. And part of the caption that went along with it is that these guys can live 10 to 20 years and they never get to have any mating. So that seems like kind of a sad life if you're an elephant seal. It's good for the green guy, but it's not good for the blue guys here. And so one of the problems with defining this is that mating systems are not easy to define because they have some complication to them. So first of all, if you're a scientist and you want to go out there and study elephant seals and how they mate, one of the things that you first have to get through is the difference between the animal's mating behavior and bonding behavior. So who you have sex with is not necessarily who you are going to remain in a paired relationship with. And so mating systems also have variation within the species. So there can be a couple of different ways that the organisms mate with one another. And then sometimes males and females vary in their mating behavior. And so one of the things we'll be looking at here is called a pair bond. This is where it appears that two individual organisms are monogamous, but that is just appearances. Scientists have lots of ways of finding out whether the babies come from one of the males. Usually with the females, you can tell if the babies came from her because you can see them physically coming from her. But if the female mates with many males, how do you know which offspring are his? So you have to do a DNA check of all of the individuals. And that can be difficult. And so one of the types of individuals we're going to look at today is monogamous birds. And so if you've ever seen the beautiful swans out there on the lake, like I think I grew up in Norton, and we used to go to Lake Anna in Barberton. And they always had the two really beautiful geese. And you never just see one. They're always the two of them together. Or if we go in my backyard right now, there's Canadian geese that are in our pond, and my son calls them Jack and Jill because they are always there and they are always together. And that is because they are monogamous. And so monogamy tends to happen very, very often in birds. It says that of approximately 10,000 species, more than 90% appear to be monogamous. So mating with one another for life. And so if we look at the difference between birds and mammals, such as humans, this is a really interesting case study because it makes you think about what are males and females capable of when it comes to pair bonding, or it comes to relationships, or to their sexual boundaries. Here, if we look at this chart, we can see here along the bottom is number of children, and then number of individuals having the number of children specified on the x-axis. So if here we have a female, and she has 0 children, it says that something like, I guess this would be, in this group of Indians, she has one that has no kids at all. And then here we have females having 1 child. I guess it's up to 8%. 2 children, 8%, 3 children, 8%, 4 children, 8%. You can imagine that because we all see that happening around us all the time. I have a brother. You see lots of 2 children families, 3 children families, 4 children families. As you start to get up in numbers, though, you don't see a whole lot of 6 children families, much less 7 children families, much less 8 children families, no 9 children families, certainly no 23 children families. In fact, at one time I looked it up of the most babies that a woman had ever had naturally. And it's not the Octomom, who was also just recently in the news. But there was a woman in Italy who lived on a farm, and she had something like 65 children naturally. She just kept having twins, quadruplets, sets of triplets, and just kept having them over and over and over again. And then the woman who was the oldest to ever give birth to a child was 67. So can you imagine? Some of us have grandmas that are 67. Can you imagine your 67-year-old grandma having a baby? Or could you imagine if you had 64 brothers and sisters in your family? That would be unbelievable. But think about that. In terms of females, not many females are going to give birth to more than 10 children. But if you think about males, males are much more capable of having lots of offsprings because they can get multiple women pregnant at one time. So the number of males in this Indian tribe, there were 4 with 0, and then fathering 1 child, lots of them, fathering 2 children, lots of them, 3 children, 4 children, 5 children, 6 children. One of the guys had 8, one had 11, and one of them had 23. I think, consequently, that 23 is the most number of child support cases against one of the Americans. That's another one of those, Google that. What are the most number of child support cases for a single man? I think it was that, because he had something like 5 or 6 women pregnant at the same time. It was terrible. So men can vary more in their reproductive success than women because nearly all women have access to a mate. So women can always find somebody to mate with them, while some men are outcompeted for access to women. So some men may be able to get multiple women, but nearly all women can get access to a mate. So this male-female difference is a characteristic of polygamy. And so going then from polygamy and monogamy, now we go to sexual dimorphism. This is an indicator of population mating behavior. And in sexual dimorphism, first starting off with mono, so mono meaning one morph, this means that the male and the female look almost exactly alike. So both parents are then going to invest approximately equal caring for the offspring. So in this set of birds, both of the parents are going to invest equally, so they'll both sit on the nest, they'll both bring food for the young. Their mating system tends towards monogamy. Because they both look like each other, there's really no way to tell between who is the male and who is the female. And both sexes are equally choosy when selecting a mate. So if you both look equally the same, then you can be equally choosy about finding a mate. And so when they mate together, a lot of birds, you can't tell who's the male and who's the female because they both take care of the young and they both stay with one another for their entire lives. But in sexual dimorphism, like when we talked about these elephant seals, this is where the male might be gigantic and the female is often a lot smaller. So one parent is going to invest more in caring for the offspring. Who's going to care for the offspring? The female, yes. The smaller of the sexes is going to be the one that takes care of the offspring. In mating systems that tend towards polygamy, so it's going to be male with lots of females. And one sex, usually the females, is choosier when selecting a mate, so she wants the biggest, baddest of the elephant seals. And one sex, usually the males, is going to compete for access to mating opportunities with the other sex. And so I wanted to show you this YouTube video, but since I don't have my multimedia cart, there is no way for me to put the sound up there. But let me, you can watch that one if you want to, but this is the one I wanted you to see. I know, it's terrible. Oh. I'm not even sure if I can turn this up. Okay, so I'm going to narrate it for you. These are the big, giant, nasty bull elephant seals, and you can see they have this appendage that comes off their nose that provides them absolutely nothing except something to whack each other senseless with. And so they will get into these fights that can last for hours, and they are unbelievably brutal. But just because they're bleeding a lot doesn't necessarily mean that they're going to die. These aren't usually like a fight to the death type of situation. These are going to be like they've got so much blubber and fat around them that when their teeth poke into them, they're just going to poke into the fat. And so they get into these huge fights, and they bash each other with that elephant seal nose that they have. And so eventually one of them appears to win, and he gets to mate with the female. And he gets to hang out and be the dominant male, and all the other males kind of go off into the background, and they don't get to have sex, and they're most unhappy about that. And so these fights can continue, and as they go along, you can hear them just whacking into each other. It's so brutal, and they have this calling. I mean, they sound like elephants. They are blowing out of their trunks, and they're bashing each other until they're bloody. Sometimes they spill over into the ocean, and they will whack each other in the ocean too. And there's the female. She's like, "Who's going to win? So then the water gets all bloody all around them, and it's just horrible. Oh yeah, and they would be open to infection really easily. So that would be. That's right. This is the Jerry Springer of the nature world. And so as scientists, it's really hard to study this because you don't want to be anywhere near these guys when this is happening. He looks so happy and cuddly, right? So, so you can see what happens. They're fighting. When you saw the female, she's so tiny compared to that male. He is just unbelievably huge. And let's see if I can. Hope this starts from here. Oh, good. So one parent invests more in caring for the offspring. So one of the things about elephant seals also is that because they're so huge, the pups are at a big disadvantage because if this giant male goes lumbering over top of you, he can smush the babies. So it's hard for the mothers to take care of the offspring. So she puts a lot of energy into taking care of them, and he puts a lot of energy into fighting for the opportunity to be the one that gets to mate. And as you can see, the biggest one may get to have all of the mating in a colony for many, many years, and some of the males may never get to pass along their genes. And so body size in this case is an important clue to behavior. So we have a level of competition among the individuals. And so when you have really big males and smaller females, you tend to see more aggression that is occurring. Think of like, what have you heard about the bull elephants in Africa? If you have two males and they're fighting for the females, they are huge, they are loud, and they're much, much bigger than their female counterparts. So when you have two different sizes, this is an important clue to what they are going to act like when they go through these mating rituals. And so selection for larger and larger body size when competition is high. So among the elephant seals, there is a great amount of competition. So the bigger you are, the better you can fight off the other males. It's also almost impossible to distinguish males from females among 90% of bird species, and that's why they are monogamous. Because if the males and the females look exactly alike, there isn't going to be this fighting because they're going to be putting in the same amount of energy to raising the offspring and making sure that their genes are passed along. So in humans, men are often bigger than women. So that would tell you something about our evolutionary pressure as we have what's the word I'm looking for? We've changed over the last 100,000 years. We know that males have been fighting for females. We haven't always been monogamous. And so this may tell us about evolutionary history. For a long time, humans were not monogamous, and many would have been polygamous. The biggest, baddest championship male would be getting all of the females. And so as these individuals are evolving and populations are evolving over the course of years and years, a lot of them have developed ways to communicate with one another and designed certain signals so that they can recognize what's going on. If you think about wolves, wolves have this very distinctive howling, and it sends out a signal to other wolves about where food is, where mates are, where the other individuals are. And so communication and eventually getting into language. So we have some forms of communication that are not necessarily language or vocal. We have chemical communication. So if you think back to our termite experiment that we did at the beginning of the school year, or at the beginning of the semester, we have chemical communication with pheromones. So releasing this chemical cocktail of smells that one individual uses to trigger another individual to get to a food source, to get to mates, to get back to the colony. And so this is a type of moth, and it's got these really neat feathery antennae. That's what these are, is its antenna. And it can pick up those chemical smells and be able to get to where they're going. So pheromones used very often in looking for mates or looking for food. We have communication, where we have any action or signal on the part of one organism that alters the behavior of another. So releasing pheromones by one individual means the other individual will follow the chemical scent or follow that trail. So in communicating, we can communicate chemically, we can communicate with behavior, we can communicate with language. And so what types of animal behaviors require communication? Often it's finding mates and finding food. Finding territory is another one. What types of communication do animals use? We have chemical, we have auditory, which is the kind of language, and then we have visual communication. So if you've ever, hey there, if you've ever seen any of the Disney movies that have pufferfish in it, anytime you scare them or distress them, they puff up. And so puffing up is like what the elephants feel. They try and make themselves look as big as possible so that they can show that they are the dominant male. Or in this case, they are conveying that they are scared of a predator or not wanting the predator to eat them. Because the predator might think, oh, I'll eat that little tiny fish. But if the fish puffs up, it gets to look like something that's too big for them to eat. So chemical communication, like in pheromones, auditory communication, like coyotes, visual communication, like the pufferfish. And so with pheromones, we can also see, or with communication, we can also see things like little dances that display certain characteristics that say, here they are dancing so that they can convey where certain flowers are, that they can go get the nectar from and bring it back to the colony. They can show where potential mates are. Again, two very important things, eating and passing along your genetic information. So scientists have asked over the years, what exactly is language? We know that humans communicate via language. Are there other types of species out there that are going to work with a complex and formal language? They've found that vervet monkeys have very distinctive sounds that they make. Long time ago, you may have remembered the gorilla. Its name was Amy. I get made fun of all the time. And the symbol for apple, and so she would make that symbol, I want to eat the apple. So they taught American Sign Language to chimpanzees and gorillas, and then human language. So what makes up language is being able to communicate to other individuals. And so as we know, just having language is not the only way that we communicate. We also communicate through our body language, through our displays. If you look around in here right now, you could probably guess who is in charge, because I am the one who is standing up. So that's often the way that you convey leadership or convey teaching. And so just our form of language has become so complex, and not having all of those signals can sometimes really screw up the meaning of those messages. So now, where it's not all written, not all oral language, where we have written language, that's why we put smiley faces on things or exclamation points to try and demonstrate what we mean behind our written language. And so something that the animal kingdom has done is made signals that are called honest signals, and these are helping to reduce deception. As you know, we can all lie about what it is that we're saying to somebody. How many times have you ever said to your girlfriend or boyfriend, "Oh, I'm fine," and you are totally not fine? So in the animal kingdom, they have what are called honest signals. So here is an example of one of those. This is a toad that makes that characteristic squeaking, croaking noise. And so female natterjack toads, and if you go onto YouTube, there's great videos of these toads. They make these mating decisions based on how loud the male's call is. So the more females that can hear his call, the more chances he's going to get to pass on his genetic information, because if the female can hear him, they can go to him when they are ready to mate. And the loudest calls are only made by the larger males. So if you are a tiny male and not very good to mate with, then you make a puny little croaking noise. But if you're a giant male and you're very physically fit and capable of passing on good genes, you're going to make a much louder call. So that's why they call it an honest signal. There's no way to fake being a bigger toad than being a littler toad, because the smaller males can't fake it. So it's an honest signal. It carries accurate information. So some of the characteristics can't be faked. It's given when both the individual making the signal and the individual responding to it have the same interests. So the individual who's making it is saying, I want to mate, and the individual who is responding to it says, I am also ready to mate. So he doesn't croak when he doesn't want to mate, and she doesn't respond to the signal until she is ready to mate. So these honest signals are going to carry the most accurate information about an individual or a situation. So what happens as populations evolve is that we start to get some deception moving into the population. This is where we get croaking by the males that is begging instead of being the most fit. So like annoying the female until she mates with him. And I have another YouTube video that I just posted today that is of this behavior in sea turtles, where the males group around the female and basically beg to have sex with her. And then we have what's called the evolutionary arms race, where we have unambiguous signals or sophisticated patterns. So males put out these very sophisticated ways of showing that they're fit, and they are not exactly fit. Hold on a second. I didn't know that was buzzing. I was like, what in the heck is that noise over there? So an organism's phenotype, the way that its physical appearance appears, is its organism's phenotype is including its behaviors. So those behaviors are passed along from, strange. The person knows I'm teaching too. I don't know why they're calling. Okay, so I'm going to leave it up to you to watch those YouTube videos on your own, since I don't have any sound. And I think that we're going to have a short day today. So thank you very much for coming, all of you.